All right, so let's start off. Question one. Question one is very common, very typical question. So what's the diameter of Earth? So these are some of the questions that you need to know. Diameter of Earth, diameter of hair, diameter of atom. Okay, so these are the typical items that they will ask you. So let's start on. What's the diameter of Earth? Can you type in the chat box? 10 to the power of. Come everyone, type into the chat box.
It is 7.
Yeah, correct. Huh? 7. 7 what? Huh? 10 to the power of 7 meters. Huh? Hair. 10 to the power of minus. Hey, come guys, type into the chat box. Minus 17. No lah, minus 4 meters. Huh? Okay, then atom is 10 to the power of minus 10. Okay. So 10 to the power minus 10 will be 0.1 nano. Okay. Then for hair, this will be 100 micron. Okay. That's for question 1. All right. Question 2. Question 2 was very tricky. Some of you fell for the trick. The 0 is at the bottom. So this number is 1, then 2, then 3. Okay. So you must be very careful where is the 0 mark. And from there, then you get the 0.5, right? Okay. Then the other one, you get the 0.18, right? Over here. Then from there, then you need to divide by 10. Okay. So that's the answer. All right. One thing to take note is for micrometer. Okay, for micrometer, the 0, it always goes from 0 at the back, from 0 to 50. Yeah. So 0 will be here. Then 50 will be at the top. Okay. So that's how one turn of the micrometer will be from 0 to 50. All right. Okay, question 3, I think should be quite okay. Question 4. David, how come you got question 4 wrong? Huh? Okay, so just be careful, okay? Okay, now everyone, let's try to convert. 1 gram per cm cube equals how many kilogram per meter cube? How many? Okay, come guys, quickly, just type into the chat box.
I see 1,000 is not
Yeah, it's 1,000. Huh?
over. Okay.
Okay, steady. Okay, question 5. What's gravitational field? Can you give me the definition first? What's gravitational field?
A
Gravitational
region
field.
where an object experiences a force.
Yeah. Okay, to be more specific, experiences a gravitational force because there's so many type of force. Okay, then what's the gravitational field strength? Gravitational field strength refers to gravitational force per unit mass. Okay, so in this case, this really refers to G. G will be weight over mass. Okay, so from here, this is where we get W equals to mg. All right. Okay. Breaking distance.
It's dependent on the mass.
Yeah. Okay. How do you use Newton's law to do this?
Inertia. Wait, shit.
Inertia.
Wait, is
Okay.
it wrong?
Okay, not wrong. But I would prefer you to use Newton's second law. Okay, N2L. Now, how do we use N2? What is Newton's second law? F equals
F equals MA.
M times A.
MA. So A equals
F over A.
F over M.
I say wrong, I say wrong.
Okay, so if let's say we are using a braking force, okay, a braking force will produce a deceleration, right? Correct?
Yes.
Okay, so what happens when mass is very big? So when mass is big, what happens to the acceleration? Or the deceleration will be big or small?
Big.
Ah,
Small.
it's very small. So what happens? So it will slow down, faster or slower. So the speed will decrease, faster or slower.
The speed will decrease slower.
Slower rate. So that's why it needs a longer stopping distance. Okay. So if this is a structured question, then I would prefer you to use Newton's second law rather than inertia. Okay. So with question 6, let's go to question 7. Like what I was telling you on in the class, this is a very common type of question where you really need to know the loss in KE will be equals to work done against friction. Okay, or by braking force. Okay, so work done against friction or braking force. All right. So half mv square equals to force times distance. Okay, this type of question must know. Really must know. All right. Okay. Question 8. Which process represents freezing? So this is very standard. Solid. Okay. This is gas. Okay, what's number 2? What does number 2 represent?
It's a gas.
It's a gas. Okay. But in this case, I think the setter refer this as a liquid. But don't draw gas like that. Don't draw liquid like that. This is wrong. Okay, liquid, they must touch each other. They must be touching. Okay. All right, now can you define freezing? What is freezing? What is freezing?
The temperature where
No, the one is freezing point. So what's freezing?
when liquid becomes solid.
So it's a change of state from
Liquid to solid
at
freezing point.
freezing point. Okay, at constant temperature. Okay, so what's boiling?
Change of state from liquid to gas at boiling point.
Yeah, but okay, so you must everyone, you must mention that it is at a certain point. Okay. Okay, what's evaporation? What's evaporation?
Change of state from
liquid to gas.
Yeah.
At
At 100 degrees.
Huh? What the heck?
At any temperature.
At any temperature below
100.
Below boiling point.
boiling point.
Ah,
Must
the
use,
grade. Oh shit.
okay. You cannot say 100, Okay, why you cannot say 100?
Different substance have different boiling
Yeah.
points.
Because this is 100 is only for 100 degrees Celsius is only for water. Okay. So if it's not water, you cannot say 100 degrees. Okay, here they didn't say it's water, they just say liquid. So you cannot say 100 degrees. All right. So evaporation is always has a cooling effect. All right. Now, why is there a cooling effect? Why is there a cooling effect? Mayan?
I don't know.
Huh? Why is there a cooling effect due to evaporation?
What's cooling effect?
Yeah. Can you explain why?
Oh, cause the more the more energetic molecules leave the liquid,
Then
left with the less energetic molecules.
and then
And then the liquid become lesser, and the left liquid is cooler.
so the total energy of liquid decreases, and so temperature decreases. Okay,
Decreases.
so that produces the cooling effect. Okay, steady lah. Okay, next one. What is meant by melting point? So what's melting point? So melting point is a temperature. So melting is, okay, let me write this down. Melting is a process. Okay, melting point is a temperature. So they are different. Okay, so what's melting point? Temperature where a
Solid turns into a liquid.
okay changes state to a liquid. Okay, so in this question, answer will be so the answer cannot be A and B. So A and B will not be accepted because it's a point. So best answer here is D. Okay. All right. Okay, question 11. What do you first draw? What is the first thing that you draw?
You draw the normal.
Draw normal. Okay. So this one, I want you to be very specific. O level must be very clear. So you must say you draw normal at the point of incidence. Okay, so this word at the point of incidence must be mentioned. All right. Then from there, you calculate the angle. So in this angle will be 35. Okay. All right. So now if I change the question, if I ask you what is the change in angle, what will you write? What is the change in angle? From here, what is the change in angle? How much will be the change in angle?
Actually, I don't know, sir.
Okay, so in this question, this is the original light ray. So the original light ray travels this direction, correct? Okay, what am I doing? Okay, travels this direction. Then if let's say there is no mirror, it will continue this direction. Agree?
Yes.
So the change in direction refers to how much did it go over here. So what is this angle?
Is
It will be 180 minus
70.
minus 35 minus 35. Okay, so that would be this angle. Okay, so you must be very careful. Is the question asking you just the angle, or is there a change in angle? If it's a change in angle, then in this case, it will be 110. All right. Okay, question 12. All right. So here we have the object, then we have the image. All right. So the image will be formed over here. So can you tell me the characteristics of this image?
Magnified.
Okay.
Inverted.
Magnified, inverted, and
I don't know.
real. Okay. All right. So when will you get magnified, inverted, and real? When will you get it? This is a projector. Correct. When will you get a projector? When? Where is the object? Object is between
F1 and F2.
1F and 2F. So in this case, the object is at 15. Okay. So the focal length must be
more than.
Where will be the focal length? Will it be more than 15 or less than 15?
More than 15.
It will be greater than 15. Okay. Then of course this image is magnified. Okay. Steady. Now, if you're asked to find where is the 1F, what will you do? What line will you draw? You will draw one that is parallel to the principal axis. Then where will this line go? This line will go to the image over here. Okay. Then this point here will be F. Okay. All right.
Okay.
Okay. Question 13. All right. How many?
But then the answer sheet say the answer for 12 is like B, bro.
B.
Yeah. Is it B?
Okay, yeah, correct. B. It should be less than 15. Correct.
Oh, it is.
Because 15 is between 1F and 2F.
Oh, yeah.
So the F must be less than 15. Thank you. Thank you, Jack. Okay, question 13. How many waves are there?
Yes.
How many waves are there? How many complete waves?
1.
Point
5.
5. 1.5 waves. Okay, let's do some definition. What's a sound wave? Sound wave is longitudinal or what?
Transverse.
No lah, longitudinal.
Oh, it's back and forth.
Okay, define longitudinal.
It moves the particles move in
Okay, so
back and forth.
David is correct. So you must first tell me it is a wave. Okay, you don't start off with particles. So it is a wave where the particles oscillate. How does it oscillate?
Parallel.
Parallel. So David is parallel, not perpendicular to the direction of wave motion. Okay. Then what is transverse wave?
Wave where the particles oscillate
So,
perpendicular.
so all
in
your
both
light
directions.
waves, light, radio, X-ray, whatever, they're all transverse. So transverse wave means a wave where the particles oscillate perpendicular. Okay. All right. So in this case, we have lower pitch means
Lower frequency.
lower pitch means lower frequency. Same loudness means
Same amplitude.
same amplitude. Okay, what is amplitude?
The distance between the crest and the equilibrium.
Okay, that's correct. The other one is called maximum displacement from equilibrium
Equilibrium.
position. Yeah, equilibrium position. Okay, also can. Or you can say like what? Let's say distance from crest to equilibrium position. Also can. All right. What's the wavelength?
Distance of one complete wavelength.
Okay, so distance or one complete wave. Okay,
Yeah.
all right. What's the wave equation? What is the wave speed equation?
V equals F
V.
lambda.
Okay, so V equals F frequency times wavelength. Okay, then what's frequency equals to?
1 over period.
1 divided by period. What is period?
Time taken for one complete wave.
Hey, what's that?
Yo, Abi, stop it there.
What?
Bro, why are you moaning?
Huh?
Why are you moaning?
Shh. Hey, don't shout.
Morning. Both are
So answer.
uh,
So let's compare A and the original. So A is
A is softer
softer and
and lower pitch.
Lower pitch.
no, same pitch.
Huh, legit? Oh shit.
How do you know?
Because how many waves?
Oh
One.
yeah,
Oh,
It's still 1.5
1.5.
way. Okay.
Damn,
Then
that's crazy.
B is
B is actually
why
louder.
no, it's
louder?
the same
Same
Wait,
loudness.
loudness.
how you know?
because the amplitude is the same.
Okay, two boxes.
Oh,
Then the pitch is
Higher.
higher, yeah.
higher. How many waves?
3.5. Is it? Wait, 1. 2. Wait, 2.5.
3.
3.
Shit.
Okay. Then next one. C.
or it's softer.
Why softer?
Same
Which one?
loudness and a lower pitch.
Same
Oh my
loudness.
god.
It's still
It's
two
a
boxes,
scam.
but lower pitch. Okay, how many waves are there?
1.
How
Not even
many?
1.
Bro.
Half.
1
0.5.
quarter.
Yeah,
It's
0.5,
half.
0.5.
Okay, the last one. Last one is
Louder,
louder. Pitches.
higher. Wait,
The same.
same, sorry.
Same pitch. Okay. All right, 14. What is hertz?
Hertz is the frequency.
Hertz is the unit for frequency. Okay. Frequency. All right. What is the audible range?
20 hertz to 20,000 hertz.
20 hertz to 20,000 hertz. Okay. What is sound below 20 hertz? So sound below 20 hertz, what do we call it?
Bass boosted.
No.
I don't know.
Infrasound. What is sound above 20,000 hertz?
Ultrasound.
Ultrasound. Okay. So in this question, answer?
It's both no. No. It's yes, no. It's C.
Yes, no.
No, it's no yes.
Why no yes?
Oh wait, yes, no, sorry. Shit. I see wrong question.
Only you can hear the whistle, bro.
Yeah, only I can hear the whistle. I'm a dog man.
Okay, 15. Where's the first sound? First sound is directly from Ben to Alan. Second sound is really from Alan, hits the cliff, and then goes back to Alan. So it's really like that. So what's the sound interval? The sound interval is really just this 99 meters, right? Times 2. Okay. So interval will just be 2 times 99 divided by 330. Okay.
What's
All right.
interval?
Interval is the time difference between first sound and second sound.
Oh, bro. I
Okay.
didn't know that.
Define resistance.
Resistance is the shit. Wait, I don't know.
Ratio of
Resistive force. Shit, I don't know.
no. Resistance is ratio of PD, potential difference, over current.
Over
Huh?
Is really stating a formula. So in this case, R equals V over I. Okay, so if you're asked define resistance, it's just V divided by I. But of course, don't write V over I. You have to say PD over current. Okay, so in this question, large resistance means what's the ratio? R equals to rho L over A. So large resistance means L is big or small?
L is big.
Big. So you want big L. Then A will be
A will be very small.
small a. Okay, if you want small resistance,
You want a small L
small L.
and big A.
Okay. Okay, based on this equation. All right. Okay, 3 identical ammeters. So current comes in. Now this current that I draw, what current is this? What is the special name we give this current? What is the name of this current?
Total current. I don't know.
No, conventional current.
Over.
Okay. Now what happens if it comes up from the other side?
Electron flow.
Yeah, then we call this electron flow. Okay. So in this question, I1, the current comes out, it will split into I2 and I3. So here, I1, what would you say? So I1 equals I2 plus I3. All right. So which one is bigger, I2 or I3? Which one is bigger?
I2 is bigger than I3.
Why?
Because wait, shit, sorry. I mean I3 is bigger than I2.
I3 is bigger than I2 because
there's no
lesser resistance.
There's lesser resistance. Yeah.
lesser resistance for I3. Okay. So your answer will be
I1 is bigger than I3, then bigger than I2. Yes, that one.
This one. Okay. Okay. Now, what is current? Current is
Zero bar.
no. I want the definition.
amount of
Rate of flow
Uh,
of
charge.
charge. Okay. What's PD?
Oh my god, not this again.
Glenn,
I know.
you should be
PD
Wow.
is
Work
the
done.
work done to drive a unit charge through a component.
drive a
Yeah.
unit charge
Now you reading off the notes,
across
bro.
a component. Okay, what's EMF?
EMF is the work done by a source in driving a unit charge around a complete circuit.
Work done by a source. What's a source?
Source
The
is like
battery.
battery.
Yeah, across the entire circuit. All right. All this must memorize. Seriously, must memorize. Okay, this one. Which one has the biggest density?
Which one is the biggest density?
Yeah,
No, all is the same one.
Oh,
same.
it's the same.
Because same material.
Same material. Okay. That is the reason. Okay, question 19. During condensation. Okay, let's define what is condensation.
Change of state
Change of state from
from gas to liquid.
at
At any
no
Bro.
at
lower
what
at what?
at what
I don't know, sir.
At
Melting point.
wrong lah, condensation
It's
point,
a
bro.
boiling point.
There's something
Okay.
called condensation
Yeah,
point.
it's boiling point.
it's the same as boiling point.
Wow, that's
Yeah,
cap.
see.
Okay, so now what is Ke and Pe of molecules? What is this that they're talking about?
Vibrator. Sorry, vibrating.
No, this one. Ke and Pe of molecule. What are we talking about here? There's a special name we give it.
KMM.
No,
Is it?
we call it
Shit.
internal. Internal what?
Internal organ.
Internal energy.
Yeah.
Okay, so define internal energy. What is internal energy? Sum of
Mechanical energy.
Ke and Pe of molecules.
Okay.
Okay. All right. Then what is mechanical energy?
Oh my god.
The work done over time.
No, mechanical energy
Shit.
equals
Oh,
sum
that one's power, right?
sum of Ke and GPE of
Oh, bro.
the entire object. Okay, so what's the difference? Internal energy talks about molecules. Mechanical energy talks about the entire object.
Yeah.
Okay, so they're very different. All right. Okay, next one. What's the speed of microwave?
If they travel at the same speed, right?
Yeah, they all travel at the same speed. So okay, let's try low frequency, long wavelength. Okay, versus high frequency, short wavelength.
Or they all travel.
Same speed.
Oh,
They all have the same speed.
3 times 10 to the power of 8.
Correct. Units.
Huh?
What's the unit?
Meter per second.
Okay, so let's start. Radio. Then
Radio. Microwave.
Then
Oh my god. What's it called?
infrared,
Yeah.
and then
Visible.
visible light, then
Oh my god.
Ultraviolet.
UV, correct, then
X-ray, then gamma ray.
yeah, X-ray, then gamma ray.
Gamma ray.
All right. Okay, users of radio wave.
Telephone.
What telephone?
Bruh.
Radio wave is
Radio,
for radios.
Radio communication, such as
Transmitters.
example. It must give like that. Radio
Walkie-talkie,
communications,
walkie-talkie.
walkie-talkie. You
And
cannot
TV.
just walkie-talkie.
4G.
The other one is no, not for G.
Television.
Television. Okay. Okay. TV transmission. Okay. Microwave.
Microwave. Microwave.
Cannot. You cannot just say microwave oven. If you write like that, you will be wrong.
Microwave.
My microwave is microwave.
For
Cooking.
Oh my
yeah, for cooking. You have to say
Really?
that.
shit.
All right. Then the other one, satellite
Phone. It's satellite.
Satellite
communication.
communication. Yes.
Okay, your mobile phone.
Why you take my mobile?
All right. Infrared.
Infrared is used for
Intruder detection.
Intruder alarm.
thermal
What else?
So you best
What
set
else?
one up. Later check
hot
out.
bodies. Hot
Hey,
bodies.
shh. Also for remote
Control.
control. What
Shit.
else? Burglar alarm.
Isn't the same?
Oh,
the
I thought burger.
Same. What else? Thermometers.
Oh.
Infrared thermometers.
Oh shit.
Okay. Visible light.
Oh, it can be used to make lamps.
Okay. It is for what?
To
In terms
look.
of communication.
Communication.
Yeah. Optic fiber.
Oh,
What's
For
that?
your internet connection.
How you cannot see? So you can see it.
Okay. Internet connection.
so I connect my phone to the light.
Yeah.
Like,
Okay. Shh. Okay. The other one for medical is
Or surgical light.
okay for medical treatment.
it is used for
Example, endoscopy. All right.
yeah.
UV,
It's used for sunbaths and sterilization.
sunbaths, sterilization. Okay. X-ray.
Radiological and engineering applications.
Okay. To be more specific, radio,
Radio wave.
logical,
What
radiological what?
equipment? I don't know.
Equipment such as
Such as
Chemotherapy.
example.
no, that one is not, bro. That one is gamma ray, bro.
Yeah. X-ray scanners.
Oh my god.
For bone fractures.
And cancer.
Yeah. Okay. Then gamma,
Yes, sir. For chemotherapy, bro.
Chemo.
I know,
chemo
bro. I undergo before, bro.
therapy.
Yeah,
Okay.
I do for Jack one.
Okay. You
Okay.
know this is like the best way to cut your hair. You don't even need to like pay money to cut hair.
The one shot haircut, bro.
Okay.
Yeah, one shot haircut, bro.
To kill cancer cells.
Yeah.
All right. Okay. Next one. Let's look at this. Define mass.
Mass is
What is mass?
the amount of
Oh, substance. In,
Amount of
uh,
substance in an object. Okay. All right. So how do you add up these two velocities? What do you draw?
Resultant force. You draw
Yeah.
parallelogram.
So draw a parallelogram. Then, okay. Then what else do you draw?
Draw the line.
Draw the resultant force.
Yes, sir.
Okay. Like that. How many arrows? Must
Two.
be two arrows. huh?
two.
Okay. So
Two
in
for
this
resultant.
question, how do you find this?
Oh,
It's
you
drawn
take,
to scale. So what do you do?
you measure the length.
Yeah, measure. So what's the scale? 1 cm to
2.5 cm.
2.5.
Speed.
meters per second.
Meters per
Okay.
second, yeah.
All right. So here the question is very specific. You need to draw letter V. So you must draw V. All right. Okay. 3.5 meters above the ground. What is the total energy?
The
MGH.
mass times
Okay, what energy does it have first?
GPE.
GPE plus
KE.
KE.
K. Where does the Ke come from?
From bouncing the ball.
From here, this is the Ke.
Shit. From throwing the ball.
Okay. All right. So how do you know questions are more tricky? Is you can look at the marks lah. Okay, if it's 3 marks, they wouldn't just ask you for GPE. Okay.
Oh.
All right. Next one. Okay, there's friction, there's air, there's speed time graph for first 4 seconds. All right. Define speed.
Speed is the rate of change of distance over time.
No need, no need over time. Just rate
Legit?
of change of distance. Okay, what's velocity?
The rate of change of displacement.
Displacement. What's acceleration?
Shit.
Rate of change of velocity.
Change of velocity.
Wow, so smart.
Okay. What's the meaning of when speed is 2 meters per second? What does that mean?
You travel 2 meters per second.
Okay, cannot. You must tell me distance increases
2
2
meters,
meters
every 2 seconds.
every
What?
second.
Oh shit, sorry. Shit,
Okay.
I'm sorry.
So acceleration is 2 meters per second square. What does that mean?
Velocity increases 2 meters.
Velocity increases
2
By
meters
2
meters
meters every
second.
second.
2 meters per second
Every second.
second. Okay.
60 seconds. Oh, shit.
So in this question, what's the acceleration? What's the formula for acceleration?
A
equals
equals to initial velocity.
v minus u over
shit.
Let's
t.
see.
Final straight. Final
Okay. Or gradient of
graph.
speed time
Time
graph.
graph.
Okay. So you can find either one. So in this case, what will you use? So a equals
12 minus 0
over
over 4 seconds.
4 seconds. Okay, so let's change the question. What is the acceleration at 2 seconds?
6 minus 0.
At 2 seconds. What's the acceleration at 1 second? 2
What?
seconds, 3 seconds. Okay, what's the acceleration?
It's the same.
Same,
It's same. Yeah.
Yes,
Okay,
sir.
so it is same. All right. Okay. So do you care first 4 seconds, first 1 second? Don't care. All right. What's the distance? What's the distance in the first 4 seconds?
Area under graph.
Equals area under graph. So equals
Half times 4 times 12.
half 4 and 12.
24.
Okay. Okay, but please take note. In case lah, I'm not saying that they will. This you must check. What must you check here?
It's a minute, I guess.
Yeah, you must check the time. Check time in seconds. What happens if in minutes?
Wrong.
Times 60.
Then you convert to seconds.
Yep.
All right. Can they ever test like that before? All right. So now, what is the magnitude of the applied force?
Sorry, what?
What is the magnitude of this applied force? So what's the resultant force here?
F equals MA.
Resultant force equals F minus
Minus 8
friction equals
equals.
MA.
Oh,
Yes,
yeah.
sir.
Correct?
So F equals to MA times A plus friction.
Yeah.
Is it?
So F minus what's the friction? 8.0, right?
Yeah.
Equals what's the mass?
2,
kg. What's the acceleration?
3,
3.
3. So in this case, F equals,
6 plus
6
8.
plus 8.
so there'll be
Ooh.
14 Newton. Okay. All right. Okay. After 4 seconds, the girl stops applying the force. Then what happens?
Acceleration
So again, so resultant force equals to F minus friction equals to ma. So what happens when F is 0? When F
Then
equals to 0, then you only have friction minus friction, right? Minus
Yeah.
friction equals ma.
mhm,
So minus 8.0 equals 2
MA.
kg, right?
yeah,
Ma. So here A equals
-4.
negative 4 meters, 4.0 meters per second square. So what's A?
A is 4 lah,
A equals to 4. How come we don't put a minus?
because it's deceleration.
Because it's deceleration. Okay. So continue the speed time graph after 4 seconds. So V equals U
FM.
plus AT, right?
Oh shit. Yeah.
What's the final speed?
12.
0. Initial
Huh?
speed,
Final speed is 0.
yeah, it's
Oh,
slowing down,
because you
right?
stop, right? Oh shit,
Yeah,
yeah.
equals to 12
12.
plus minus 4 t. Yeah. So from here, you will get t equals to 3 seconds. All right. So if you go back to the graph, then you will get one line. It slows down. Then after 3 seconds, so it will be 7. It'll be like that. Okay. Okay, total distance.
Speed times.
Distance equals area
Total.
under graph
Oh shit, yeah.
equals half. So let's go back to the graph. So total distance will be
Half
total
times
area?
7 times 4.
Yeah. So half times 7 times 12
Is
Okay.
Oh my god. My bad.
goes to whatever meters. All right. Okay. Okay. Question 3. How do you do this? Okay, let's define what is moment
Moment is the force
product of force and distance. What distance?
perpendicular distance
From?
from the pivot.
No, from line of
Shit.
Symmetry.
action of force to pivot.
Sorry, what?
Okay, what is line of action?
Line of action. Oh, the
Yeah.
amount, the force is it?
So if you look at this tension, this tension is here, right? Then this red line, this entire line is, what do we call this entire line?
Line of action.
Line of action. Then the other 36 gram, it will have a weight, right? Then this line is called line of action.
Yeah.
Okay, so question, where is the weight of the ruler?
Oh, in the middle.
In the middle. Okay, we try not to use the word middle. What do we use?
The center of gravity.
Thank you. So let's do this again. All right, what is principal moment?
Force anti-clockwise force is
Too
shit.
fast at equilibrium. Sum of clockwise moments equals
equals
about,
anti-clockwise moment.
no, about a
pivot.
pivot is equal to
The sum of anti-clockwise moment.
anti-clockwise moment about,
A pivot.
No, about the same pivot. Huh?
Oh,
Okay,
shit.
please be very careful. You have to use the correct terms. Okay, then what is CG?
Sorry, what?
What is center of gravity?
Center of
Your
gravity.
weight.
Center of gravity is?
We are ruler.
No, a point where the entire weight of
Is
an object appears to act. Okay. All right. So if I give you one object here, where's the weight?
the middle.
Cannot say middle.
The center.
Okay. How do you show working? What working do you show?
I got working on me.
Yeah. You must draw dotted line. Then da 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 da. Then another dotted line. Okay. Then da 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 da. Then you find the CG. Okay. You must show dotted lines as working. If they ask you to draw lah. Okay. So in this question, what's the mass of the ruler?
36. Wait, shit, no.
No, so you must draw moments. Okay. Is this CM, ACM?
This is ACM.
ACM. Okay. Then another one from the weight of the ruler.
CM.
Then this is CM. Okay. Do you need to convert 36 gram to weight?
Yeah.
No
Wait,
need,
no
for
need,
this
no need.
question, no need. Why no need?
Because I don't know, man.
Because it will cancel out at both sides. Okay, so ACM equals to CM, then 36 times
36 times what's that?
42 minus
42 minus 15.
15 equals mass times
S times perpendicular distance.
which is 50 minus
50 minus 15.
42.
Oh shit.
Okay, then you will get your answer. All right. Okay, why we ignore T? How come T is not included in the calculation? Why is T not included in the calculation?
Because it is not anti-clockwise or clockwise.
Okay, so the pivot, okay, I'm going to draw this as a pivot. Okay, example. The pivot is the pivot is here, right? Okay, so what is the perpendicular distance? Perpendicular distance of T to pivot. What's the distance? What is the distance?
Wait, where's the pivot?
Where is the pivot?
Wait, I thought you shit.
So this is the line of action of T. I'm talking about T. Then the pivot is also there. Okay, so what's the perpendicular distance?
0.
0. So what happens when distance is 0?
Then no
Moment equals
0.
moment equals to force times distance, right?
Yeah.
So it will be 0. Okay. So that's why we don't need to talk about T. Okay. All right. State what will be observed if the 36 gram mass is shifted to the 20 cm mark. So what happens when the 36 gram is shifted to the 20 cm mark? So this becomes 20 cm. What happens to the ruler? Will it turn or will it not turn? So will the ACM become bigger or smaller? ACM will increase, decrease?
Decrease.
So it will decrease, huh? All right. Because the moment is force times distance, right? So when the distance decrease, the ACM will decrease. All right. So now what happens now is that the CM is bigger than ACM. So what happens? The
You will tilt,
ruler will turn or tilt
turn clockwise.
clockwise. Okay. So that is this part of the question. Okay. All right. Okay, last question. Then we'll stop. Okay, heating element. How does the heating element heat up the water?
So what do you mean by heating element?
Heating element is the heater lah, this thing here. This one. This heating element. Okay. So let's define first. Everyone, let's define what is conduction? Heat transfer
Through contact.
by
Huh?
heat transfer without movement in medium. Okay,
Yeah.
by
Contact. No.
by there are two
By
processes.
the movement of particles.
By passing of vibrations from more energetic particles to less energetic neighboring particles. Okay. What's the second one?
Convection.
Or number two,
Oh.
by flow of free electrons.
Oh.
Okay. All right. What is convection? Convection is heat transfer
In a medium.
Without
with
medium.
bulk movement in a medium due to differences in
The movement. Is it?
densities. Hey, these are words must use. I really try to cut down a lot of words already, but must use. Okay, so you will say the less dense hot fluid rises,
While the
denser
cooler liquid, fluid
cooler fluid
sinks.
sinks. Okay. Then what is radiation?
Radiation
Heat
is
transfer through infrared radiation. Okay. So when do you use good emitter? Good emitter. When do you use good emitter?
a good emitter.
Yeah, when do we use good emitter? When it is a black surface, rough.
Surface.
What else?
Dull.
Dull. Okay, so all this must say, must mention the word surface. All right. Okay, when do we use emitter? When the object is hot or cold? Hot, then the surrounding is?
Cold.
Surrounding is cold. Okay, good emitter, good absorber.
White.
Same thing,
Black roughs.
Okay, then when do we use absorber? When the object is
Cold.
cold, and then the surrounding is
Hot.
hot. Okay, when do we use poor emitter?
When do we use?
Yeah,
When the object is
when the
what?
surface is
Shiny.
white,
White, shiny.
silver, shiny, what else?
Smooth.
Smooth. Okay, so the mention also again must mention the word surface. Okay, then same thing, object is hot. Okay, when do we use good poor absorber? Same thing.
When
All right, when the object is
cool, right?
yeah.
In the surrounding spot.
So poor emitter means object is hot lah. Okay, surrounding is cool. Okay. All right. Okay, then what are the things that we need to talk about when we answer such questions? We must always start off with property of material first. Then what does the property do?
Oh,
Does it promote or reduce heat gain or loss? And then by conduction, convection, or radiation. Okay. All right. So for example, what about trapped air? Trapped air is
Good
a
insulator.
poor conductor or good insulator. Then what happens? So it will promote or reduce?
Promote heat loss. Heat loss. Wait, no. You will reduce heat loss.
Reduce heat loss
Yeah.
by
By
conduction.
conduction.
Okay, so it can either reduce heat loss. Oh yeah, it can only reduce heat loss. Okay. So example like that. So in this question, describe how the heating element heats up all the water. Then what will you say?
You heat up the water first through
3 marks. So you will say number 1. Water nearest heater. What happened?
by conduction.
through conduction.
Yeah, gains heat by conduction. Then what happens? The less dense
Less dense
hot water
rises, while
rises.
the cooler,
The
denser water sinks.
cooler water sinks. Okay, then what happens? Cycle.
Creates a
Cycle repeats. Creating or forming
convection current.
2. Heat up all the water
Efficiently.
uniformly or efficiently. Okay. Steady?
Yeah.
Okay. We will stop here. Please continue with this question 5, 6, 7, whatever, all these other questions. All right. Then okay, especially static electricity. We have not done static electricity for some time already. Okay, and then electricity. Okay.
Richard, can you go up to
Yeah.
like the Noddy Road?
I will send the recording out.
Oh, okay.
Okay. Yeah, this one.
Yeah.
Yeah. Okay, I will send you all the recording.
Thank you.
Okay, then tomorrow, do you want to meet up? I can meet up. I actually want to meet up to do waves and light.
Can.
And
And okay, I'll send out. It's optional. I'll send out the Zoom link.
Okay.
oh wait, what time?
3 o'clock.
3. Sure.
Do you have lessons tomorrow?
No, yeah, I mean, don't have a tomorrow got assembly or something, isn't it?
Okay, I'll send out the time lah. Okay, see you guys.
Okay, bye bye.
Bye, Joe.
Bye bye.